a little bit of discussion here on what it is exactly we're doing. We're looking for factors to help us build a greatest common factor. A factor is a number that can be divided into another. Now, that may seem kind of strange. Maybe not, but here's what we mean by that. When we start talking about factors, let's say, for instance, we have something like the number 12. Now, normally when we talk about factors, we usually don't include 1 because when we go to build something, 1 doesn't really do anything to it. But if I try to think of the other numbers that are divisible into 12, 2 goes into 12 evenly. And if I wasn't sure, I could always try dividing it into the calculator. 3 goes evenly into 12. 4 goes evenly into 12. 6 goes evenly into 12. Well, and so does the number itself. So when I'm doing these, I have to have a little bit of an idea of some numbers that divide in, but I don't have to know every single one. How we use those to build the greatest common factor is what happens is when we multiply I'm trying to think of a word that would make the most sense here. We multiply the common factors of 2 values. And we're going to actually get to the example here. We're going to use our example down below to do this. So, first thing I'm going to do is I'm going to do this first one with method 1, showing you based on the chart from yesterday. So if we were doing it like we did yesterday, if we saw 14 and 28, we'd look at the chart and we'd say, okay, I want to find a column somewhere that has both 14 and 28 in it. So I start looking around, I'm like, okay, there's 14. Ooh, there's 28. Okay. So I look and I'm like, so it could be 2, but wait a minute. 14 and 28 are right here too. And we always talked about getting the biggest one. So I'd look at it and I'd say, okay, there's 14. So for these two, my GCF is going to be 14. But what if I don't have the chart? Now, what if I'm somewhere doing this, I don't have my chart available to me, what can I do? Here's what we're going to do. We're going to list the factors of each number. So here's how that works. We're going to take whatever number we're starting with, like 14, and we're going to try the smallest numbers that we can find to divide into it. Well, 2 is about as small as it gets. It's still going to get somewhere. You're like, oh, 2 does work. Okay. So 2. And then I look at 7. I'm like, 2 doesn't go into 7, or 3, or 4, or 5. So actually, what I'm going to end up doing is those are the 2 numbers that can multiply to get 14. So I'm just going to leave those for a minute. I know there's more blanks, but I just put them there in case we needed them. 28, I'm going to do the same thing. And again, I always want to start with little numbers. So I'm like, okay, so 2 works. Now can I divide that number by 2 again? I can. So I use another 2. However many times that value will go in, I got to keep counting it. And then we figured out before 7 only has 1 value left. And here's how finding the GCF works. You look for the values that both your lists have in common. Notice it's 1 to 1. I can't circle this 2. I know I see it, but that one's already been taken up. And then you just multiply those like numbers together and you get the same thing. So you have some options here that are available to you to be able to do it that way and circle them. So I want to try a few with this way of writing down the factors and then circling in case you don't have your chart. Then we can go back to the chart too on some of these. Now, if you know your factors, well, shoot, that's even better. Like for instance, 14, we just did 14. We know it's 2 and 7. So 2 and 7. But then 20, again, always start with the little ones. Okay, so 2 goes in. Okay, that's good. Let's see, does 2 go in again? It does. But then 2 doesn't go into 5 or 3 or any of those other things. So I go back and I look and I say, okay, what number or numbers do I see in both lists? Well, each got a 2, but I don't have another 2 to circle. Those are different. Oh, my greatest common factor is 2. And again, this is going to be really helpful when we start factoring here starting tomorrow and being able to figure those things out. Now again, some of you may say, okay, this is kind of tedious. And again, if you've got a decent grip on division, it won't take forever. If you don't have a good grip on division, this can take a while. And 2 can also divide into 2. And you're like, oh yeah, I kind of see how that would work. 2 times 2 times 2 times 2 is 16. Okay. But again, I'm always going to look. Now here, ooh, I don't think 2 is going to work this time. Let me check. Nope. So then I try the next biggest number. I go, okay, what about 3? Okay, 3 works. Nothing else goes into 7 though, except 7 and 1. So those are my 3 factors. And again, I just go looking for the ones that are in common. But here, again, I'll just mention the chart, and again, they're in the folder from yesterday if you'd need one. You could look through and say, okay, let's see. Now, here's our dilemma. Because you look and you're like, well, 2, 16 and 42. I should be able to find that in the 2 column. Well, charts only grow so big because I see here that 16's in my 2 list, but I get down to the bottom of my chart and it's 30 and I don't see 42. Well, if this kept going, I'd see that. You're like, well, shoot. So if you do that sometime and try to use the chart and you see one of your numbers there, like we do in this case, try dividing the number at the top of that column in and see if it goes in. That could be your factor too. Well, let's get to something a little bigger. Let's jump down to 4. And again, the quickest way to go with this is just start with those smaller numbers. If they go in evenly, cool. If they go in evenly, try that same number again, and we always like the smallest ones first. And then I notice 3 is at the end. Well, 3 is only going to go into it in itself. And if you're not sure sometime, 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And then I just do that same thing, but I keep starting each time by dividing by 2 for as long as I can. You're like, yeah, 2 doesn't go into 9, but 3 does, I'm pretty sure. Yes. And don't lose that last one, because you can still divide 3 by 3. So this time I got a few more to play with. They each have a 2, they each have another 2, so I can use that. As long as they all have the same number of them, I can. They each have a 3. So 2 times 2 is 4. Times 3 is 12. And again, if I were to go charting, there they both are. And there's my 12 row. So I have options. One last one down here at the bottom, and then we're going to kind of see which way we want to go with the best here. Now, we haven't had this happen too often. Divide by 2. Oh, fraction. No. Okay, let's try the next number up. Okay, 3 works. Oh, since it worked that time, let's see if it works again. 3. Oh, yeah. And then nothing goes into 5. Okay, we're just using the division buttons. But always go for the little numbers first, because otherwise you're going to have to break the numbers down again anyway. So 30, okay, 2 worked. I don't think 2 is going to work again, so let's try 3. 3 worked. And then I got 5 left over, which I know nothing's going to go into 5 but 5. Look for the ones that are the same. Multiply them together if there's more than one. Get my answer. And And again, we've got to be able to find this greatest common factor, though. It's critical moving forward with factoring to be able to do this. Makes factoring really hard otherwise if we don't know how to do this. So, let me flip back over. Now, when we get to the back, I'll be honest, I usually do not do a whole lot with factor trees, just because that gets kind of crazy. So I'll show them to you, but I'm not a big fan of this. So 14, if you remember back before we did, it was 2 and 7. Well, 2 and 7 don't break down anymore. So I write them down that way. 28, now here's how you work when you're going to do a tree. You take two values, and you go, okay, two numbers that multiply to 28. The two that come to most people's mind right away are 7 and 4. Well, 7 doesn't break down anymore, but 4, you're like, oh, 4 can be divided by 2. So it's basically, you're doing the same thing you were doing on the front, you're just making a little tree with it. So you list the tree, you write down the numbers like they did here, and then you find the ones that are in common, multiply them together, and get your answer. Like I said, not the biggest fan of the tree. I much rather would have you just write down the factors like we did on the front, or use the chart to do the same thing. So actually for these last two, we're going to use the chart just to give you some options here on how this could work. So let's see here. 18 and 30. 18 and 30. 18 and 30. Okay, 18 and 30. I see 3. That's a possibility. Ooh, 18 and 30. 6. The bigger the number, the better. There's an 18, no 30. There's a 30, no 18. 6 looks to be the magic answer here. And it actually would be. Because if I were to write these out individually, and I'll do that part for you on this just so you can see the connection. 30, I'd have 2 times 3 times 5. And I'd go back and I'd look for the ones that are alike and multiply them. Okay. But you notice how much quicker the chart went. And like I said, the chart's not infallible. It's going to have some shortcomings, but for a lot of these, it's going to help. 45 and 60. Start looking through. There's a 45. There's a 60. Okay. Oh, there's a 45 and a 60. Ooh, that's a bigger number. 45 and 60. 15. Okay, let's see if this works. 15. So if I had 60, it'd be 2 and 2 and 3 and 5. Like I said, I'm just doing the division stuff for you like we were doing on the calculator. And then 2 won't go in there, but 3 will, and 3 will, and 5 will. Find the ones that are alike and multiply them together. So that's what we're looking for on these. Our big goal here is to find those multiples, multiply the common ones together, and work it out that way. So then, what I'm going to have you be working on, and again, I'll keep the notes handy, is we're also going to bring back in what we were doing yesterday with the variables. So, a couple of reminders. We're going to find the GCF for our coefficient. And again, coefficient is just a fancy word for the number in front. And then for the variables, we're going to make sure all terms have it. In other words, if there's 3 terms, all 3 of them have to have that letter. Otherwise, I can't use it. And then we're going to use the smallest exponent. So I want to work through some of these with you just to get us thinking a little bit. And then for the on how this is going to go. So I think what I'll do is I'm going to do this top row here with you, 1, 2, and 3, to get you a kickstart. Okay, first part, I got to look for the numbers. Now again, this is just me. If you want to individually do numbers for 15 and 30 and 90, you can, and I'll do that for one of these too. I'll do it for number 2. But for this one, if I'm looking for 15 and 30 and 90, I start looking, I'm like, okay, let's see. Okay, there's a 15, there's a 30, ooh, come on, 90, all right. 15, 30, and 90. So 15 would be my coefficient part. And then I go through and I start looking at all the variable terms. And if I see all of them have it, so I'm like, okay, so M, I got an M, there's M, okay, they all have M. But I take the one with the smallest exponent. So I'd have M, or M to the first. Then my N's, that has N, that has N. Oops, that doesn't have N. I can't use the N's unless all 3 terms have it. So that's going to be my greatest common factor, 15M, or 15M to the first. Now, if you're more comfortable with what we have been doing, you can go ahead and say, okay, yeah, I'd rather just do this and kind of just do the division thing because it's easy and I can do the same thing every time. Well, 2, we know 2's only factor is 2. There's nothing else that's going to help us. 9, if I try to divide it by 2, doesn't work. So I try the next number. I say, okay, 3. Oh, 3 and 3. Okay. Oh, I knew that. I knew 3 times 3 is 9. And then 18, same thing. Try 2 out, unless you know it's not going to work. Then you're like, oh, it's back to 9. Well, I know what 9 is. 3 and 3. Now, again, when you're doing this, you have to be careful because you have to find a number that's in all 3 lists. You're like, well, wait a minute. There isn't a number in all 3 lists. 2's in these 2, but it's not here. 3's are in both of these, but it's not there. Well, what do I do then? My LCD then, if I have no numbers in common in the lists, it's going to be 1. Okay, and that's only when I have nothing in common. For the rest of them, now I just go through looking at the variables. X, 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 okay. Take the one with the smallest exponent. So X, or X to the first. Y's, all 3 have Y's. But here's my one with the smallest exponent. And I get my answer that way. So again, when you're doing these, the key is going to be 2 and 8. Okay, I know that's going to be 2. This, I don't need a calculator. I can do this in my head. 8 divided by 2 is 4, so 2 goes in. 4 divided by 2 is 2, that goes in. And 2 divided by 2 is 1, because 2 times 2 times 2 is 8. So again, if you want to look at it that way and say, okay, there those are, my number part of my LCD is going to be 2, that's cool. Variables, they both have A. I take the smallest exponent, which is 3 this time. And I look at my B squared, and my smallest one is just B, or B to the first. That's what I'm looking to do on these. Just to be sure, I want to do one more. I want to do 13, because the number's a little weird. Actually, no, I see a better one. Let's do 17. All right. 17. 72. Oh boy. Just to let you see, sometimes these may go a little while. All right, so 72. I got a 2. Let me try dividing that number by 2, because again, I'm just going to keep dividing by 2 as long as they'll let me. Oh, 18. I think 18 is divisible by 2. Oh. But 9 isn't. You're like, no, but 9 is 3 times 3. So instead of just getting 1 or 2 factors, I can get a lot sometimes. And then I just do the same thing with 36. Like, okay, so 18 divided by 2. And you know what you're going to find? You're going to find that as you do these more, you're going to get to recognize some of these numbers' factors right away. Even when you're typing them in the calculator, you get to a point where you're like, oh, 9 is 3 times 3, and just go about your business. And again, every 1 for 1 that you can match up, we circle, and then just multiply them together. So 36 is my numeric part of the GCF. I look at my variables. They both have an r. I take the smaller exponent. They both have a t. I take the smaller exponent. And I'm good. So this paper is your second assignment in homework check number 13, okay? The one of these that we did yesterday with greatest common factor would be your first. And then the homework check, again, if you still need to work on some of those, that's okay. Just turn it in with the cover sheet whenever they're done. And actually, all 4 sheets are still available over there. I checked this morning, and I got all 4 of them up here in order. So if you need any of them, just kind of look at them, and then you can get those out of the folder